My name's Sam Marsh. I'm currently branch president of Sheffield UCU. I'm also an elected negotiator for UCU in the national discussions over USS. The purpose of this video is to talk you through a spreadsheet that I've put together. Now, this spreadsheet models the valuation of the pension fund, and it does so according to various assumptions. So we can vary the assumptions, see the effect on the fund. So I'll talk you through the columns that are here. It's not as complicated as it looks, but let's start with the summary at the top, where this spreadsheet summarises what it's found under the main assumptions that people have been discussing so far. So, for example, the September valuation, this was the first valuation that USS produced. They claimed this showed a 5.1 billion deficit, and my spreadsheet pretty much agrees. It came up with a figure of 5.0 billion for the deficit under those assumptions. The November valuation was where USS intensified the de-risking because UUK asked them to, and this led to a deficit stated by USS of 7.5 billion. This spreadsheet agrees that those assumptions give 7.5 billion. The final row on this left-hand side here is something that hasn't been sort of very widely known in the public arena, I guess. This is what happens if you cancel all de-risking but leave all the other assumptions the same. What happens to the deficit? Now, this spreadsheet says you end up with just a £500 million deficit, so almost no deficit. Now, USS have never publicly released a figure corresponding to that, although a representative from USS came to Sheffield to talk to our working group here, and he did there tell us that under those assumptions it should be a £500 million deficit. So this spreadsheet agrees with what USS know to be the case, even if they haven't publicly said so. Right, now over on the right hand side at the top here, there's some stuff relating to best estimate assumptions. Now, I should stress that best estimates are what we call the median guess. So in some sense it's the best guess of where things are going to end up. Now, you can't run a pension scheme based on best estimates. So in some sense these best estimates aren't relevant. Well, they're relevant, but they aren't as relevant as some people would like to think they are to the situation. Now, again, what we're doing is comparing what this spreadsheet says with what USS have released. So, for example, under the September assumptions, USS published a best estimate of 8.3 billion surplus for the fund. So that's what they think is the most likely outcome, is that we've got 8.3 billion too much. My spreadsheet underestimates it. I'm not quite sure why. I think it's related to the cash flows that are being used to calculate that. I'll explain a bit more later perhaps. But my spreadsheet says 7.6 billion surplus. In November, under the revised valuation, USS said that the best estimate had now fallen to 5.2 billion. Why was that? Well, because of the de-risking. The expected returns on the investments will have got lower because of the de-risking. And this spreadsheet pretty much agrees, says 5.1 billion, slight underestimate. Now, this is another figure that USS have never released at the bottom here. That is, what's the best estimate if you do no de-risking? So my spreadsheet, I think, comes up with a number that's likely to be close, probably an underestimate, and that says if you don't do de-risking, your best guess at what happens is you've got £11.6 billion worth too much of assets at the present time. Okay, so that's a big number. Lots of people are focusing on that number. It's not perhaps as relevant as the 0.5 billion deficit over here, but it does mean something. It's the best guess of what's going on at present. Okay, and USS have never publicly released that data. In fact, when I asked at a joint negotiating committee meeting for that number from them, they told me they didn't know that number. They hadn't modelled it because it's outside of Universities UK's risk appetite. Okay, so they say they didn't even know it. Well, I'm telling it to them now. It's about 11.6 billion. Right, so where do these numbers come from? Well, they come from various columns on this spreadsheet. Okay, now, this all comes down to what we call discounting liabilities, which is a way of adjusting future payments to take account of investment growth. Why would you need to do that? Well, the rough idea being that if you need to pay £20 in 20 years' time, you probably don't need £20 in today's money. You need a bit less that you allow to grow with your investing plan. and then it hits £20 in 20 years' time. So future payments you don't have to account for as being worth as much as they seem in nominal terms. You kind of discount them according to a discount rate. And USS published the discount rate in September, and it looked like this. So what they've given is a percentage figure for each year. So this is how much they expect their investments to grow for each year going on from 2017 into the future. Oh, this zero doesn't mean they expected zero growth in 2017. That's just we're starting at zero. Okay. So that's the first column. So this first chunk is all about September. Here's the discount rate. The second column here is the compounded effect of that discount rate. So overall, by 2037, under the September assumptions, you'd have expected your investments to be worth 87% more by that point. Okay, so that's what that column means. So it's just compounding the first column here. Right, the key thing is this column, I guess, which is the liabilities discounted by this discount rate. So the rough idea being that each year you pay out the benefits that are due. So this is under the assumption that the scheme closes to new accrual, which is part of the valuation. You ask, what's the total amount of money we need to pay what we've currently promised? So by the end of the first year, you've paid out £2 billion worth in today's money, and then by the end of the second year, it's more like 3.7, and so on. And the idea is that the total value of the liabilities is the figure at the bottom of this column. So as we scroll down, you see the number getting bigger and bigger. It starts to kind of slow down as you go far into the future, because those future payments start to fall off, and also the compounded discount rate means you don't need much in today's money to pay the small amount in the future. Okay, so eventually you settle on 65 billion in 100 years' time, having been paid out. Okay, well that's 5 billion more than the assets we currently have. Hence, if we go right back up to the top, this 5 billion deficit up here. Okay, so the other columns are just variations on that. We have things like, suppose we started with 65 billion, what would happen to the growth of the assets? Well, this is assuming you don't pay any payments in this column, which I guess doesn't mean much because we're also always going to pay things off, but that's a column I had. This is those figures discounted back to today's money. I won't go into that too much. This column's a bit more interesting. This is what happens if you start with 65 billion and pay off these liabilities, and you see that you end up going down to zero. Okay, and then some other relevant calculations here which discount the figures either according to the inflation assumptions or according to this discount rate. So I won't go into those too much. If you're comfortable with this kind of thing, you'll figure out what those columns mean. Right. Okay. So there's a chunk of the spreadsheet, and then the idea is this spreadsheet repeats that chunk multiple times. So as we move across, we get the same kind of things with the November valuation. Scroll to the bottom of the liabilities column, and you get to 67.5 being paid out over the next. This is billions of pounds being paid out over the next 100 years. That's 7.5 billion more than we currently have, hence the 7.5 billion deficit in the November valuation, etc., etc. Right, so then other chunks that I've got are the USS assumptions, but with de-risking absent. So that's so the discount rate stays higher than in other places because the de-risking doesn't occur. And here, of course, if you get to the bottom, you find that you only need 60.5 billion, which is 0.5 billion more than we've currently got. So a 0.5 billion deficit. Then we have various columns for best estimates. So the best estimate according to the September de-risking, best estimate according to the November one, best estimate with no de-risking. That's where you find this huge figure of an 11.6 billion surplus by noticing that under the best estimate condition with no de-risking, you only need 48.4 billion pounds worth of assets to pay the liabilities. Now this chunk should be treated with caution. This is to do with the self-sufficiency calculation. I know that the cash flows needed to value this are different to the ones that I've been given, so this is all kind of, yeah, and the discount rate has never been published, so this is all kind of estimates that don't quite get to the right numbers because I haven't got the relevant data. Right, now what's all this based on? Where's this secret data that USS don't want you to know about? Those who've been following what I've posted on Twitter will know that I was given some cash flow data which allowed me to make these calculations, and then I was told that cash flow data was top secret. So it's not in any of the things I've shown you so far. These discount rates are public, so that's not the issue. The issue is all the way over on this side of the spreadsheet where I've blanked out the figures. These are benefit payments, so the total benefit payments that USS expect to pay over the next 100 years, and the expected contributions that that they expect to come in if the scheme remains open. So this is the kind of data that's secret that I've had to blank out and you're not allowed to know about at the moment. Perhaps by the time you listen to this video that data will be public. Who knows? Let's hope USS change their mind. Right, now there's some other really interesting information, at least I think it's interesting, on this spreadsheet, which is to do with test 1. Now here's some more public data that that I have left in this spreadsheet. These are USS's CPI assumptions, so the inflation assumptions. This is what happens if you compound the inflation assumptions. Here's the salary growth assumptions that USS have got. They look rather pleasant. We're currently about to ballot over pay. These figures I'm sure would see the ballot called off. And this is what happens if you compound the salary growth according to this column. Right, and then we have some stuff related to test 1, which is all to do with what they call their reliance on covenant metric. I won't go into that too much at the moment. But the interesting calculations come in here, which are to do with what the position of the fund is like in 20 years' time. So suppose you allow the fund to continue in precisely the same way as at present, what would things look like in 20 years' time? If you ran the valuation there. So you pretend you're in 2037. Now USS supplied me with some cash flow data, which is over on the right hand side of the spreadsheet, that allows the calculation to be done, and essentially it's the same thing as before. You start again from scratch in 2037, you compound your discount rate, you work out the paid liabilities, the benefit payments that go out, and you discount them according to the discount rate. So that allows you to arrive at a figure for the liabilities in year 20. Now according to the November valuation, so if we de-risked according to the November valuation, then the total amount of money we'd need to cover our liabilities as at 2037 would be 112.5 billion. Now that sounds like a lot more than than we were discussing for the present day. Of course that's because these numbers don't take account of inflation, so everything looks more in 20 years' time. 112 billion won't seem like 112 billion in 2037, but still the liabilities have grown. Now the interesting thing is how that compares to what we call the self-sufficiency valuation, stuff like that, and how it compares to what would happen if you allow the assets to just grow, the fund to remain open and the assets to grow anyway. Now the big finding that I think I'll focus on for now, I think if you're following so far you can probably figure out what's going on in this section of the sheet yourself, but one of the big findings is this one. Start with 60 billion today, which is what we've got, and what we had as at 31st of March 2017. It's already more like 64 billion. Okay, what happens to that 60 billion if you pay out the benefits that are due and take in contributions at the 26% total rate, which is what we currently are paying? So basically what happens if you continue the scheme as it currently is? Now the fascinating thing is that by 2037 you would expect, this is under prudent assumptions with de-risking, you would expect to have 112.2 billion pounds in 2037. Okay, well just stop for a minute and compare with what we expect the liabilities to be worth in 2037, and you'll see that that's 112.5 billion. So in other words, if the scheme remains open for the next 20 years and we keep paying jointly with the employers 26% into the scheme, then in fact when we run the valuation at 2037, if things have gone according to plan, we only have a 0.3 billion deficit. Okay, now that's rather hard to reconcile with the fact that we have currently a 7.5 billion deficit under these assumptions. Now the reason for this, this is for this paradox, if you like, I can't go into right now in a video. Mike Otsuka has written an excellent blog post about it, talking about hidden prudence built into various valuations. That, I think, is behind this this thing that looks like a paradox. This needs to be studied further and commented on further by anyone who feels comfortable in taking apart such arguments, so please do get involved if you can. Hopefully the data that is blanked out over the right hand side of the spreadsheet will be released by USS in time. I don't quite see what the problem with it is. It's not personal data in any way, not sensitive data. They just don't want people to see it, perhaps because it allows people to totally figure out what's going on with this fund. Anyway, that's for someone else to judge. Okay, I think that's where I'll leave this video. It's long enough already. If you do have any questions, Twitter's not a bad place to fire them at me. So I hope you found that useful.